Good morning. This is a recording for Thursday, October 4th, and we're going to be working on our notes for 1-8 today. And there's a bunch of people at the tour, manufacturing tour. And so I'm just going to go through these couple first slides over again. So this is 1-8 three-dimensional figures. Can you identify, name, find surface area, and find volume of three-dimensional figures? This is considered kind of a review of things you've done in the past, just to kind of get us back on track with our shapes and things like that. And then after your quiz yesterday, you had a time to look at these things. And then we went over that, I think, in most hours right at the beginning or at the end of the hour. So then you should have all gotten 3 handouts yesterday, and I'm just going to go over what this one says. We did a little highlighting in first hour, but I don't know exactly where we left off in all of the hours. So there's no key terms page here, but there is a lot of definitions and things like that on this handout. So a solid with flat surfaces that encloses a single region of space is called a polyhedron. Each flat surface is called a face, and the line segments where the faces intersect are called edges. Points where 3 or more edges intersect are called vertices. And then here are some examples of polyhedrons as we look at that. And so polyhedrons have to have flat surfaces for their sides. So polyhedrons are prisms which have a base on the top and bottom, are connected by, in the state of Minnesota, what we focus on, they're connected by rectangles. And so this is a right prism, and it's just like the one that's on the smartboard there. And we can have them where these sides, instead of being rectangles, they're parallelograms, and that's called oblique. And we do not focus on oblique things in this class. And then a pyramid just has one base. Bases are faces. So when you list the faces, you also list all the bases as well. And then things that are not polyhedrons but are very familiar to us: the cylinder, the cone, and the sphere as we look at those. So just some reminders of shapes that we've had before. And then the sphere is kind of just three-dimensional set of points in space that are the same distance from a given point. And a sphere has no faces, edges, or vertices. And I should go back to a cone. A cone has a circular base, and it has a single vertex. So a cone does have a vertex, and it has some kind of base shape that is a circle, but a sphere doesn't have any faces, edges, or vertices as we look at that. Then some things are named by their shapes, and you saw these in real life, you know, if you did the little self-quiz thing. A triangular prism. Notice that this picture, and today I'm going to write in yellow, and then because I'm telling you to notice and people are not in the room. So notice on this picture that that's a triangular prism, and the bases are the triangles, right? So even if it sits like this, the bases are here and here. They're in the front and back instead of the top and bottom. So you do have to look at that carefully as we go through things. And then a rectangular prism, and notice that one on the smartboard looks like it might be a cube, but it doesn't have to be. And we saw with those little tiny ones, the blue ones, that I had several different ones as well. And the unique thing about these solids is sometimes we can, if it's a rectangular prism, we could pick almost any two sides to be the bases, and then the rest are faces as well. Pentagonal prism, triangular pyramid, rectangular pyramid, or square pyramid, and pentagonal pyramid. And so a polyhedron is a regular polyhedron. Oh, well, yellow is not going to work as a great color right now. A regular polyhedron, if it's all of its faces, all faces are regular congruent polygons, and all edges are congruent. And there are 5 regular polyhedrons called the Platonic solids, and because Plato used them extensively. And so these are called the Platonic solids. You are not going to be required to know any except the first two. The first two, we will use these words. A tetrahedron is a triangular pyramid made out of 4 equilateral triangle faces. And I don't think any of mine are tetrahedrons. I have several of them. And this one you can tell is definitely not a tetrahedron. So this is the triangle, and that is probably an equilateral triangle. Give me a head nod. Do you agree? It looks kind of equilateral, the one that I'm holding here. And but obviously that is equilateral, but these are not congruent to it, correct? They're a lot taller, and they're not equilateral. And then this one is my other one, this little blue one, and it almost looks like it could be, but if I take off the bottom, which is a little equilateral triangle, and I kind of put it on there, just you can see that those are not the same, right? So it's not quite a tetrahedron, but it's close to a tetrahedron. And it's a triangular pyramid no matter what, as we look at that. And then the hexahedron or cube. Hexa means 6. It's 6 squares that are all identical, and 6 square faces. And then we'll just look at these other ones. An octahedron is 8 equilateral triangular faces. A dodecahedron is 12 regular pentagonal faces, and an icosahedron is 20 equilateral triangular faces. And kind of that's how many you need to put those together. And I will not require you to know those, just the first 2 there as we look at that. And then, I feel like I should have had another handout here. Oh, which I do not. I may have deleted that. Oh, that's not good. Let me look at this other handout. And I believe that I accidentally did that. So then your next handout, that small handout, that's the one that we'll look at next. And that is surface areas and volumes. And I do apologize, but I'll have to kind of look for that unless I know. Somehow I got rid of that. So my apologies there. Just remind me, this is 1/8, correct? Okay, thank you. And so I'll just pull it up on a different Smart Notebook page, and then I'll put it in for the rest of the day after this. But this next handout is right here. And this is then on surface area and volume. Just a reminder of units. So when we were doing perimeters before, we were using just the units. Surface area is an area, so we use square units, and then volume, we're taking usually, if it's a basic prism, we're taking the area of the base, which is length times width, and then times height. And a few of these, you'll have to be careful of the heights as we go. So the first thing is the definition. Surface area is is a two-dimensional measurement of the surface of a solid figure, and it's the sum of the areas of each face. And truly, if you forget some of these formulas, you can just find the area of all the faces, add them all together, and that is the surface area. But we do have some kind of quicker ways to do that. And volume is the measure of the amount of space enclosed by a solid figure. And just someplace on there, you should write yourself a little note that perimeter is in units, surface area is in units squared, and volume is in units to the third, just so that you're aware of that. And so if we have a prism, and that's this one on the left here, we can kind of think of unwrapping. I'll wait a minute until you get something written down about those units, because I do want you to know that. We can think, though, of unwrapping the shape and kind of seeing what we get when we unwrap it. And if we take this, and there's something called a net. If I look at this I'm holding a square prism, so it has a square on the top and the bottom, and it has 4 rectangles that are all the same. If I kind of unfolded those rectangles, they would kind of look like this. Pretend those are all the same, and then the little square top and bottom would be like that if I unfolded it like that. So we know to find the area of a rectangle is length times width, so we multiply those 2 dimensions. But if you think about it, we can make this whole thing as one big rectangle, and then this bottom dimension is just the perimeter around the bottom here, that perimeter adding up all those sides, whether they were the same or not. And so if we take the perimeter times the height of the prism, then that gives us the area of all of those. And then if we find the area of the base, which will just be, this length times width, whatever that shape is, and then times 2, we'll get those as we go. So I'd like to just go through quickly these formulas. So surface area, and again, I'll use this yellow marker, and then I'm going to get rid of all the yellow, just so that I know I've said it. So the perimeter here, surface area, is the perimeter of the base. That's the perimeter around the edges, and they're showing that at the top as well. And you can use the top or the bottom, it shouldn't matter, times the height of the prism, so it has to be all the way up and down like that, and then times or plus 2 times the area of the base. So that is giving us that base and that base. So whatever that shape is, and this capital B stands for the area of the base. So the base might be a square, it might be a rectangle, it might be a triangle, it might be a hexagon, and then that might be a little harder for us to find, but it is something that we can find as we go. So that's how we're going to, to find those things as we go. And now I have to just erase some of that. And then volume is this area of the base times height. So it's like area of the base and then kind of filling it up layer after layer after layer and getting that total thing as we go. And then on a regular pyramid, the thing with a regular pyramid is we're finding the areas of these triangles that are kind of tipped, and so the height of that triangle we call L, which is called the slant height. So we find the perimeter all the way around there, and since these are triangles, we take that perimeter times this slant height, and that's like our base times height, and then divide by 2, which is same as multiplying by 1/2. So, and then 1 capital B, because there's only one base as we go. And that might be a rectangle, a triangle, a square, kind of anything as we look at that. Then surface area of a cylinder, and remember it's kind of the areas of all these. And so The first thing we do, if you think of having a can and a soup label, and if you take that label off, do we all agree that it's a rectangle? Just give me a head nod. So yeah, it's a rectangle, and then I could kind of attach these two circles. So this dimension along here is really going around that circle, and that is the circumference of that circle. And circumference is 2 pi r. So we really take this as the circumference of the circle times the height of the cylinder, and that gives us the area of that kind of soup can label. And then pi r squared is the area of a circle. When we multiply that by 2, we get kind of both of those as we go. And then the next one is the cone. And oh, and I didn't do the volume for that one, the cylinder. The volume of a cylinder is the area of that circle that's on the bottom or the top, whatever you want to call it, times the height. So pi r squared times h. And again, if you want to have all of these, some are on the 11th grade formula sheet, but all of them are available for you to use for quizzes on your handouts, and then when we take a test, you can kind of use those as well. And then same thing, this slant height is right here. Never on these are they talking about like a height on the base. Those heights you kind of have to find, and these L's are slant height, and then H is always from the top to the bottom or the bottom to the top. So that height is right there. This height is right here. You don't need this height except for the volume there, and they didn't draw it in, but it also would go to the middle of the bottom, and the height of this one is all the way up and down. And so if I use a pencil and these little blue ones, I can kind of identify the height. It's where my pencil would go right to the middle, and they all have little holes in them to kind of see what happens there. And so that's all things. So for the cone surface area, it's pi RL plus pi r squared. The volume of a cone is 1/3 the volume of a cylinder. And so I'm going to, for those of you who aren't here, you just kind of miss out on this. I'm going to take, there we go, my cone and my cylinder, and I'm just going to, visually show you. And this is water, a water bottle I just opened, and I do spill, but you know that it's water and it'll dry and it'll all be okay. So how many times should I be able to fill the cone and dump it in the cylinder? 3, because my formula says that this is 1/3 pi r squared h, and this is pi r squared h. And so these have, that looks like the Tin Man to me, but these have the same circle on the bottoms as the bases, and their heights are the same, just, they are. And, and then I dropped it. So here we go. There it sits, and hopefully you can see it well enough. And here is 1, and you can maybe tell that's about, 1/3 of the way. I'm not very good at pouring. And I missed some, so could I do worse? Well, maybe I could. Don't press me there. And so 3 of those filled that perfectly. So, we kind of, sometimes I think, hydroplaning. That's what that's called. Wow. That was a little first for me. So I just made my cylinder hydroplane on the table, so that was kind of exciting for me. And so aren't you sad you missed geometry today when you're at this tour of manufacturing? But you're finding out great stuff about manufacturing, so that's awesome. And then surface area of a sphere is 4 pi r squared, and then volume of a sphere is 4/3 pi r squared. And I am not going to, pour any more water. I'm just saying. And so make sure you've said something to yourself about units as you go. And then we're going to go back to our actual handout. Now I'll insert this slide that I accidentally kind of got rid of. And now we're going to our kind of long handout. And these are the problems. I maybe said something about this yesterday. These problems are long to answer. So I'm just telling you right up front, I know they're long to answer, but they're not hard to answer. So that's kind of the good news as we look at this. And so let's just take a minute, and I don't even know where anything is today. Let's take a minute and look at these problems and kind of see what we come up with. It says determine whether the solid is a polyhedron, then identify the solid. If the solid is a polyhedron, name the bases, faces, edges, and vertices. And if it's not a polyhedron, we're going to name what we can, because we'll still be able to name a few things as we go. So let's just kind of see what happens here. And Robin, what would you call that? Yes, and then what kind of polyhedron is it? Give me kind of a name off of there. A rectangular prism. And so I'm writing yes because we determined it is, and it's a rectangular prism. And we're not going to do a lot of naming, or excuse me, finding volume and everything else because we don't know measures. But we're going to, if it's a polyhedron, which it is, we're going to name the bases, faces, edges, and vertices. So bases, and for this, whoever I call on, you kind of get to pick what you're saying are the bases. Right now, I would pick maybe the top and the bottom. And these are all rectangles. Give me a head nod. Do we agree? We could say all of these faces are going to be rectangles. So Tana, go ahead and pick what you want to be a base. Rectangle is the word you're going to say. Rectangle, something, 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 something. So our bases are rectangle. And so maybe you're going to name that one. GHFE is one of them, and if that's, we'll call that one of the bases, then we're committed to the other base, and I forgot that I should be pointing at you. And what is the other base going to be? That was the top, so this other base is going to be the bottom. And what might you call that? Comma and CABD. So those are the bases. Then we're going to list all of the faces. And when I list the faces, the bases are faces. So without even asking anybody, I'm just going to relist those. So rectangle, and I should have put an S there. So I've got GHFE, comma, and I've got CABD, and I know that for faces there are 6 of them, so that's 2 of them. And then when you're ready, tell me another one. AEGC is this one over here. AEGC, and then you can tell me another one. FBDH is the kind of this side, right side, I would call it. FBDH. I need 2 more. One of them is what? AEFB, and I'm going to trace it AEFB. It's kind of that back part of the box. AEFB. And the last one I'll say, I think it's this front of the whole thing. And so that is GCDH. And we just go around the shape as we go. So you can see naming all of the faces, it's not super hard, but it is a lot of things to write down. And I'll just kind of keep erasing off of here. And the next thing we need is all of the edges. And They are segments. So when you name the edges, I'm going to ask you to say the word segment and then just start naming them. And I'm going to ask you to name like, there's a lot of them. Name 4 paws, name 4 more paws, and name 4 more paws. Because I'm gonna trace them as you say it. So you're gonna say segment, whatever, whatever, and tell me 4 segments. Okay, so now I'll write them. Segment EF, segment FB, segment BA, and segment AE. So I've caught up to you now. Now tell me 4 more. Okay, so segment AC, segment CG, segment GE, and segment GH. And then one more set of 4 segments, and this time I'm going to write them just as you say them. Okay, and so segment HF, segment DB, segment DH, and segment CD. And now maybe you'll know why I'm tracing those and doing them in little sets of 4, just so that I make sure that we get them all and that it all works out. And then the vertices, we just have to list all of the vertices as well. And the vertices are just these points. So vertices. And so if I didn't give you great room for these, oh no, I did not. Well, I knew through the curriculum, but will you just read off the vertices for me there? Say it one more time. Okay, and the vertices are just each of those points as we go through, so the vertices are pretty straightforward to answer. And I do see I did not give great room for those. So if you eked into that next problem, I think maybe, do we agree that this problem had a lot of answers? I think the next one has even more, correct? So we'll do some of these, maybe not all of these as we go. So first, give me a head nod. Is it a polyhedron? Yes or no? And it's a polyhedron. And so name that polyhedron for us. What would you call it? Okay. And so we'll write yes, hexagonal prism. And do you agree this has even more things to name? So I think we'll just kind of look at it and make sure that we could name everything, but I'm not going to make you write it down. Okay, so if you're listening to this, we won't write it down. So just name the bases for me. And so the bases are those 2 hexagons. So you're going to say hexagon, and then you're going to say just the letters around in order. And we're not going to write them down, we're just going to listen to that. So what are the 2 bases? Yep, hexagon, KLMNOP, and what else? And hexagon EFGHIJ. So those are the 2 bases. If we were going to list all the faces, we would list them again, and then we would list all the other faces. So we're not going to repeat those 2, but the rest are all rectangles, and maybe I'll trace some kind of in yellow so I can keep up with you. But we're not going to write them, we're just going to say them. Start by saying rectangles and start listing them off for me. Okay, so LFGM, got it. MGHN, KEFL, KPJE, and I'll kind of KPJE is that one. Okay. PJIO, and the last one, ONHI. And so there are all of the faces in addition to the first two that we had listed, which are bases and faces. So I'll kind of get rid of all of those. And then we need to hear all of the edges. So all of the edges, and I will trace them while you say all of them, segment, 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 and then I'll list them off for you. Go ahead. Okay, and I think you said them all, right? Okay, so I maybe won't say them exactly in that order, but segment KE, segment LF, segment MG, segment NH, segment OI, segment PJ, segment KL, segment LM, segment MN, segment NO, segment OP, segment PK, segment EF, segment FG, segment GH, segment HI, segment IJ, and segment EJ or JE, whichever one. So do you agree that it's not hard, but it's a lot of answers? So that's why we're going to omit kind of doing that. So that was the edges, and then we need all the vertices. So go ahead and tell us all the vertices. Just each. Oh, I think did you say, sorry? Yeah, you said G. So say this one next. Yep. Okay, and so the vertices are just each of those points. And again, I won't read them necessarily in the order that you read them, but K, E, F, L, J, P, M, G, I, O, N, and H are all the vertices. The next one, so we're kind of compensating for using a lot of room that we didn't have for the A, and then kind of not doing the rest. The next one, is this a polyhedron? Yes or no? Look again at your little handouts. And yes, it does not have all flat surfaces. And what's it called? It still has a name. Yes, it is called a cone. So no, it is not a polyhedron, but it is called a cone. And it has one thing that we can name. What can we name? Yes. It has something that we can name. Actually, I think we could name the base. What's the base? It's a what shape? Circle. So we can say something about the base, which is circle. T, capital T, and it has no other faces, and really these aren't faces because it's a flat surface, but it's not a polygon. And edges, it really doesn't have edges. It looks like it has edges, but since it's three-dimensional, it does not. It does have a vertex. What's the vertex? Vertex is W. Vertex is W. So if it's not a polyhedron, we can't always name all of the parts, but we can name at least some of them as we go. And we'll maybe say those another day. Then this next one, we want to do the surface area and volume of this cone as we go through it. And so I like to kind of write some kind of preliminary things over here. First, I'd like you to notice that the radius is 3 centimeters. The height is actually that one that goes up and down through the middle there. So the height is 4 centimeters. And then this 5 centimeters is called the slant height. So that's L, is 5 centimeters. The slant height is L. And for a cone, I'd like to know the formula for surface area. S equals what? Okay, and your calculators can handle all of this as one calculation. Pi times the radius. And so will you substitute those things into me? And so tell me what we're going to say. So I have so far S equals pi. What am I going to multiply that by? And then do what? Okay, and take a minute, type that in your calculator, and I don't know where my notes are, so I can't exactly say what that answer is, but, oh, here they are. But we'll round that to the nearest, just a second and I'll tell you. We'll round that to the nearest, either 10th or 100th, I can't remember, to the nearest 10th. To the nearest 10th. And did you get an answer yet? Oh, no. Did you get an answer yet? 75, S is approximately 75.4 square centimeters. Did you use the pi key or 3.14? The pi key. With the pi key, you get this. Guess what? With 3.14, you get this exact same answer because these are small numbers as we go through this. Then will you tell me the formula for volume? Okay, and then go ahead and substitute in for me and just tell me what else to write. And then take a minute and see what you get. We'll see what that is to the nearest 10th and when you have an answer. And this one also, if you use the pi key or 3.14, you get the same answer. Volume is approximately 37.7. And since it's volume and wait a minute, something's wrong here. Oh, what should that have been? Squared, right? And you must have done it, yeah, correctly. So since we're taking radius times height, centimeters times centimeters times centimeters, it's centimeters cubed or centimeters to the third as we go. So make sure you have that formula correct because I just did not write it correctly as we went through. So finding surface area and volume of a cone, we're following those formulas. That works out pretty straightforward for us as we go. Then what I'd like to do is I think I'm going to just pause here. And our class is over at 9:15. But what I'd like to do, I'm going to pause a moment, and if I have chance, I'll go back to the notes. But let me push the pause button, and I'm going to return quizzes, and I'm going to have everybody check your mid-quarter grade or your grade sheet if you have your Chromebook.